Texan Global School. Signs of trigonometric functions. In this class, we will analyze the trigonometric functions in the plane and the signs of their ratios. Let us remember the order of the quadrants in the Cartesian plane. In a counterclockwise direction, quadrant 1 has positive coordinates. In quadrant 2, the abscissa is negative and the ordinate is positive. In quadrant 3, the abscissa and the ordinate are negative. And in quadrant 4, the abscissa is positive and the ordinate is negative. Now, the signs of the trigonometric functions are determined from an angle in normal position, in the case of quadrant 1, or its reduced angle in the case of the other quadrants. We can see that in quadrant 1, the coordinates in the plane have their abscissa and ordinate positive. Due to the Pythagorean theorem, the hypotenuse will always be positive. Therefore, all trigonometric ratios are positive. In quadrant 2, the abscissa is negative and the ordinate is positive. Similarly, the hypotenuse will always be positive due to the Pythagorean theorem. By putting in the ratios, we can see that sine and its reciprocal are positive. All other trigonometric ratios are negative. In quadrant 3, the abscissa and the ordinate are negative. Again, the hypotenuse is always positive. Therefore, the tangent and its cotangent reciprocal are positive. All other ratios are negative. And in quadrant 4, the abscissa is positive and the ordinate is negative. Due to the Pythagorean theorem, the hypotenuse will always be positive. Putting in the ratios, we can see that the cosine and its secant reciprocal are positive. All other trigonometric ratios are negative. The following table summarizes the signs of the trigonometric functions in each of the quadrants. In quadrant 1, they are all positive. In quadrant 2, sine and its reciprocal cosecant are positive. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and its secant reciprocal are positive. We can also visualize the signs on the plane according to each quadrant. In quadrant 1, they are all positive. In quadrant 2, sine and cosecant. In quadrant 3, tangent and cotangent. And in quadrant 4, cosine and secant. Let's see an example. We will obtain the trigonometric functions given the secant of theta equal to -2. Remember that the secant is equal to the hypotenuse divided by the adjacent leg. Therefore, the hypotenuse is equal to 2 and the adjacent leg is equal to 1. Due to this ratio, we can have two possible solutions that fulfill this function. In quadrant 2 and in quadrant 3. In both quadrants, the abscissa is negative and the hypotenuse is always positive. Using the Pythagorean theorem, we will obtain the other leg. As we can see in the triangles on the plane, the opposite leg is positive for quadrant 2 since the ordinate is positive, and for quadrant 3 negative since the ordinate is negative in that quadrant. Since we already have the sides of the right triangle, we can get all the trigonometric ratios. We can see in the table that for both quadrants, the secant of theta equal to -2 is fulfilled as a condition given at the beginning of the problem. The difference lies in other trigonometric ratios, since in quadrant 2, the ordinate is positive, and in quadrant 3, it is negative. To finish, we will obtain the angle theta. Any trigonometric function helps us to obtain the angle. However, it is suggested to choose the one that has its positive ratio, since if we choose the negative, the calculator can give the angle in normal position. So we must get the reduced. To avoid this, we choose a trigonometric function with a positive ratio. So for quadrant 2, we choose sine of theta equal to square root of 3/2. Solving for theta, we get an angle of 60 degrees. For quadrant 3, we choose the tangent of theta equal to the square root of 3. Solving, we get exactly the same result of 60 degrees. In this way, we can see the two possible solutions given the secant of theta equal to -2, in quadrant 2 or in quadrant 3. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com